welcome back to Josh Does Math. In this video, we're going to be using the definition of a derivative to find the derivative at some x value x naught. And here's our equation that we're given right here. Our equation is f of x is equal to 2x squared plus 1. So that's just some parabola here. The parabola is stretched by 2, and then you end up shifting it up 1. So that's what this looks like as a graph. My goal is to find the derivative at x naught. Okay, and to do that, I'm going to be using the definition of a derivative. So the definition of a derivative says that f prime of x is equal to the limit as h approaches 0 on f of x plus h minus f of x all over h. So I'm taking the limit as h goes to 0. Okay? And I know what f of x is, so I just plug that in. Limit as h goes to 0 of, I'm going to skip the beginning part because that'll take a little more work, but the second term right here is f of x. Well, I'm explicitly given that up here, so that's easy. I just plug that in. There we go. For the beginning part, I have f of x plus h, which means instead of f of x, doing x plus h, in for every x, I'm going to stick x plus h. So just write out the same f of x here, but I'm plugging in x plus h for every x. So that just becomes 2. Instead of x, it's going to be x plus h squared plus 1. And that's all over h. Okay. Now, I'm trying to solve this limit, and the first thing that I would do is try direct substitution. In other words, I'm going to try to put in a 0 for every h. Well, if I do that, you can tell that we end up getting 0 over 0, which is an indeterminate form. You can't tell what this means. Same thing with infinity over infinity. If you ever get that, that's another indeterminate form. And there's maybe 5 other ones, but these are the 2 most fundamental indeterminate forms. If you get these, you did something wrong, because these don't tell you any useful information. Instead, you want to get something that's not either one of these. And how do you do that? Well, you just manipulate your limit using algebra. So I'm going to use FOIL up here and distribute the negative sign. So I'm writing limit as h goes to 0 on 2. Now I'm going to do FOIL right here, x squared plus 2xh plus h squared. Then I'm adding 1. Then I'm subtracting. I'm going to distribute the negative here. 2x squared minus 1. Negative 2x squared minus 1. That's all over h. Okay, so I'll write that again, except this time, how about we cancel that positive 1 and the negative 1? And how about we also distribute the 2 for all of those terms at the beginning here? I'm rewriting limit for each step, because that's what you're supposed to do mathematically. We're still taking a limit. That hasn't changed. Plus 2h squared. And I'm canceling that positive 1 with the negative 1. So this just becomes minus 2x squared. That's all over h. And as you can see right here, we got this term up here and this term up here. That term cancels with that term. And we're just left with this mess involving h's. And there's a factor of h on the top and bottom, which means that I can cancel that h. And up until this point, if you were to plug in 0 for h like we initially tried, you would have got 0 over 0 for each time you tried it. But now this is the step that changes it, because I'm dividing by h on the top and h on the bottom. I'm factoring out that h and It cancels in the numerator and denominator. And now that it cancels, I can plug in h. I can plug in 0 for h. And if I do that, I get 4x plus 2 times 0, which is just 0. So this becomes 4x. So 4x is equal to f prime of x. If I want to figure out f prime at x naught, all I do is for x, plug in x naught. So this becomes 4 x naught. So this is giving me the instantaneous rate of change at some x value, x naught, on the graph, 2x squared plus 1. That's what this is telling me.